Hi guys, back again with chapter 2. So it's 2.1 frequency distributions in their graphs. Now I will tell you these notes are going to be long and tedious, as I'm sure you can tell by your packets. It's going to take a lot of work, but it's simple material. It's just a lot of writing, a lot of work. But we're going to learn how to make frequency distributions and then do their graphs, and I'm going to split it up amongst 2 days. All right. So in this section, you're going to learn how to organize data sets by grouping the data into intervals called classes and forming a frequency distribution. Frequency distribution is just a table that shows classes or intervals of data entries with a count of the number of entries in each class. The frequency f of a class is the number of data entries in the class. That's pretty self-explanatory. We're going to break all our data into classes, and then the frequency, or f, is the number of times that the data falls within the class. Here's an example of a frequency distribution. So as you can tell, we have our class, and then we have it broken up into categories. So it's 1 through 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25, and 26 to 30. You see that all of our classes are the same size. They're all 5 different numbers. So frequency f is the number of times that it falls within the category. And so for the class 1 to 5, there are 5 different times that it falls within that 1 to 5 range. For 6 to 10, it's 8 different data points that fall within the 6 to 10 range. Okay, so in the frequency distribution shown at the left, there are 6 classes. The frequencies for each class are simply 5, 8, 6, 8, 5, and 4. Now that'll give us our total amount of data if we add those up. So it'd be 13, 19, 27, 32, and 36. So you should have 36 total data entries if you were to actually look at each one and break it down. Okay. Each class has a lower limit. So it's a lower class limit, which is the least number that can belong in each class. And then it also has an upper limit, which is the largest number that belongs in each class. So your lower limit for the first class is 1, and your upper class limit is 5. 6 for the lower class, and 10, 11, and 15, 16, 20. You get the point. Class width is the distance between the upper and lower limits of consecutive classes. Notice that your classes do not overlap. The distance between the maximum and minimum entries in a frequency distribution is called the range. So if I was asked to find the range, it's the distance between the maximum, which would be 30, and the minimum, which would be 1. That would be your range of the frequency distribution. Whereas if I was asked to find class width, it would be the distance between 1 and 5, 6 and 10, 11 and 15. I realize I'm going kind of fast. You'll need to pause this video so that you can write all this down. So you'll have to pause it a bunch of times. Okay. Oops. That's definitely not the right one. That's better. Guidelines for constructing a frequency distribution. First, decide on the number of classes to include in the frequency distribution. Number of classes should be between 5 and 20, otherwise it might be difficult to find any pattern. So if you say, well, I'm only going to do 2 classes, you're not going to be able to see it. And if you are, then we're going to learn different ways that you can handle that data so that it wouldn't be a frequency distribution at all. Step 2, find the class width as follows. So here's how you can't just randomly assign a class width. So first you're going to decide how many classes there are going to be. Then you determine the range of the data, divide the range by the number of classes, and then round up to the next convenient number. So let's say that I decided I wanted to have 6 classes of data, and my range would be 35. Now I purposely made it a number that's not going to be pretty. So I divide the range by the number of classes, 35 divided by 6, which is going to give me 5 point, who knows, 5.7, something like that. But you're going to round up to the next convenient number. So you're going to make your class width 6. Then you find the class limits. So you can use the minimum data entry as the lower limit of the first class. So the smallest number that's in your data, you're going to use that as the lower limit of the first class. Then define the remaining lower class limits, add the class width to the lower limit of the preceding class. So you're going to add the class width to the lowest limit of the preceding class. Then that will give you your lower limit of the new class. Then find the upper limit of the first class. So you would just subtract 1 from the lower limit of the new class. Remember that classes cannot overlap. Then you find the remaining upper class limits by adding the class width to those upper class limits. We're going to do multiple examples of this. Fourth step, make a tally mark for each data entry in the row of the appropriate class. Then the fifth step is just to count the tally marks to find the total frequency F for each class. Okay, now we're going to go about constructing a frequency distribution from a data set. So the data set lists the prices in dollars of 30 portable GPS navigators. Construct a frequency distribution that has 7 classes. So it's telling us already that we need to have 7 classes, which means step 1 is taken care of for us. So we have this entire list of numbers. The first thing that I would really do is look for my lowest number. So if you look for your lowest number in this set of data, I believe it's going to be 65. Then I'm going to look for my highest number. In this case, it's going to be 340. We have 2 of those. Doesn't matter that there's 2 of them, as long as you find the highest number. So far we've found the highest and the lowest, which according to our steps for guiding frequency distribution, now we need to find the difference between these two in order to find what I had listed as the distance between the two. You just have to find the difference. So you're going to do 340 minus 65. You're definitely going to want to use calculators for this, just because of the mass quantity of numbers that we're going to be doing. So that's 275. So that's your range. Okay, so the next step in this process was, if you remember, to divide the range by the number of classes. Well, we have 7 classes, so we're going to do 275 divided by 7. And then you round that up to the next convenient number. So if you do 275 divided by 7, it gives you 39.2. Which we're going to go ahead and round up to 40. That's the next convenient number. So the next step is to find our lower limit by using the minimum data entry is the lower limit of the first class. Then you find the rest of the remaining lower class limits. So that's how I do it. I'm going to find the rest of my remaining lower class limits. And I'm going to create my chart. So I've created my chart or my table. Now I'm just going to find my classes, frequency, which is F. Then my lowest class starts at 65, right? Then I go and find my next lower class limit by adding 40. So that would be 105. And add 40 to that, 145, 185, 225, 265, and then the last one would be 305. Then, to find what this number would be for my upper limit, I just take the 105 and subtract 1 from it. So it would be 104. Then what they say is that you should add 40 to each one of these. I said just, it's one less than your lower class limit here. So I don't know why you would go through that process again, but so it's going to go from 185 to 224 to 264, then to 304, And then for this last one, you're just going to have to add 40 to it. 344. Now, your next job is to literally just tally them up. What falls within each class. So how many are going to fall between 65 and 104? 1, 2, 3, 4, 5, 6. And that's it. Hopefully. This is literally the part that I'm the worst at. I don't know why, but I really can't see it sometimes. So anyways, so far I got 6. In between 105 and 144, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In between 145 and 184, 1, 2, 3, 4, 5, 6, 185 to 224, 1, 2, 3, 4, 225 to 264, 1, 2, 265 to 304, 1, and then the last one is in B2. Because we crossed every other one out. So tedious, takes a while, but it's simple. All right, if we add all this up, we should get 30, because there were supposed to be 30 data points. 6 plus 9 is 15, 6 plus 4 is 10, so 15 and 10 is 25, plus 2 plus 1 plus 2, that gives us 30. So we did it right. And that's all there is to a frequency distribution. Now I want you to pause the video and construct your own frequency distribution of the ages of the 50 most powerful women. Use 7 classes. This one, at least we listed it out from the lowest to the highest. Makes it a little nicer, actually. So I broke this one down step by step for you. So first, state the number of classes that was given to us. And it's going to be 7. Find the minimum and maximum data entries in the class width. So our maximum data entry is 86, minimum is 26, So you do 86 minus 26 gives you 60. And then to find the class width, you do 60 divided by 7. So it gives us 8.5. Now, it says that you can do the next convenient number. So you could make that 9 for your class width. You could also just round it up to 10. The only difference is it's going to mess up your data a little bit. So I'll do a class width of 9. And find the class limits. Now when I'm doing my class limits, I'm just going to scroll down to the bottom and start my table. So there's classes and frequencies. And then my first one starts at 26, and then I'm going to go up by 9. So it'll be 35, 44, 53, 62, 71, and 80. And to find my upper limit, remember I do this number minus 1, so give me 34, 43, 52, 61, 70, and 79. And then I have to add 9 to this to get 88. Now comes the fun part. We just start counting. But since I put your numbers in a organized way, it makes it a little easier. So we're how many up to 34? It's just 2. Then from 35 to 43. 1, 2, 3, 4, 5. 44 to 52. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 53 to 61. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 62 to 70. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 71 to 79. There's only one of those and one of those. Okay. So when we add this all up, it should equal 50. So 2 plus 5 is 7, plus 12 is 19, 19 plus 18 is 37. This would be 48, 49, and 50. So we did all right. Then we can expand frequency distributions to include more data. So we can go and include the midpoint of a class. So it would just be a 3 column chart. So it's the sum of the lower and upper classes, of the lower and upper limits of the class divided by 2. So the midpoint is called the class mark. So to find the class mark, take your lower class limit plus your upper class limit, divide by 2. You're just finding the average of the lower class limit and the upper class limit. So if we went back to this example here, it would be 26 plus 34 and divide that by 2. And so your class mark, we would take this table, add another column to it. Oh, that's nice. Make that class mark. That would be 30. And then you just keep doing it. 35 plus 43 divided by 2. So maybe 39. Now, they're very rigid in their rules, right, for how you construct this. But instead of doing 44 plus 52 divided by 2 the whole way down, once you find that first class mark, it's the same way that it was here. If you added 9 to it to get from here to here, you can do the same thing with your midpoints. And so we just add 9. It'll be 48. Add 9 to this. This will be 57. And 66. 75. And 84. Does that make sense to everybody? Because to go from this lower limit to this one is 9. So you're just adding, you're going to add 9 to your, from your lowest class mark to get to the next one and all the way down. All right, see it says 2.1 continued. Attention. Nice work today. Assuming you actually did work today and didn't watch Criminal Minds. All right.